Welcome to SolidCAM Professor on our series of Getting Started. I'm Sydney, your SolidCAM Professor, and in this session we'll be doing our second part in 2.5D milling. What I'll be doing in this part that we see on our screen is I'll be walking you through all the steps that we've done in all the operations, showing you every single machining operation that we've done here, such as this surface here, the top over there, these areas over here, the flip side, including our home positions, basically everything that was done in this particular part. If we take a quick look at our home positions, you'll see that we have one home position facing up and this second home position on the flip side to do the second side. Our stock material is a box around the entire part itself, as shown over here. And obviously my target is the part itself as illustrated over here. Now, in our first operation, we'd like to clear this area over here. So what we've done here is very simply, we've done a profile operation with a clear offset to clean out this area. If we open up the operation itself, you'll see that we'll be using a profile where the geometry is simply just that line and nothing else. The tool that I will be using will be a 10mm end mill. My levels, my upper level will be 0 and my profile depth will be up until that step itself. In my technology, we'll be doing a rough cut, leaving a 0.5mm on the wall itself. And if we go down now to clear offset, you'll see that we have a clear offset between this area and this area of 30mm, stepping over every 8mm to clear the step. And we're also going one way. In other words, we're going across, going back up, and that's how we're clearing across the part itself. Our link will be using tangent for both our lead in and for our lead out. If we take a look now at our simulation of this part itself and we use Solid Verify, you'll see my tool goes down, clears the entire step, and you'll note that it cleared this entire area before it goes down to the next level, then goes down to the next level, and then finishes off the part. We have complete control also as far as how it steps over. If we go back to our technology area, you'll see that we did complete Z level. In other words, completing the entire step on one Z level and then doing the next step on the next Z level. If I were to cancel my complete Z level, then what would happen is it'll actually go down on that area and then work its way over to the next step, again clearing that entire step down. Take a quick look at that simulation. Also, you'll see that this tool this time makes one step over and then will complete that step and only then move over, instead of what we had before, clearing the Z level all across and then going down. We have both of these options. Now let's continue with our third operation. In this operation, what we've actually done here is machined this area around here. If we go into the operation, we'll see our geometry is this area as shown over here, going around the part over there. And our tool will be the exact same tool we used last time, our 10mm tool. Our levels, our upper level this time is from over here because all of this area above has already been machined. So we only have to machine from this level here up until this level as shown over here. In my technology, we're basically using the exact same thing we did last time. We're doing a rough cut, leaving a half a millimeter on the side, stepping down 2.7mm each time, and we're doing one finish cut because this short area over here, it's not that deep, and we'll also be doing a step down of 2.7mm. Our link will have a lead in of a tangent and again a lead out of an arc. And again, if we take a look now at our simulation using the Solid Verify simulation, you'll see that the tool will go down and clean up that step with rough cut, and now clean it with the finish cut up until the very end. Now this next operation, I'd like to start working inside this pocket over here, as shown in this operation here. We've gone down and cleaned out wherever we can within that pocket. Let's just take a quick look within the operation itself, and you'll see that my geometry in this particular case is that pocket over there. The tool again will be that 10mm end mill, and my levels will be the upper level over there, and the pocket depth will be up until the bottom of the part itself, going all the way down to the bottom of the part, as shown over here. In the technology area, we'll be going down our usual contour option, and in our link, we'll be going down in a helical fashion. Let's take a look at our simulation, and if we use again the Solid Verify simulation, you'll see that the tool goes down and mills out whatever it can mill out in this particular area. Now in this next operation, I'd like to clean out these areas over here, as shown in this operation. So I'll simply show you what has been done over here. My geometry is the outside and the inside border, because I do not need to work over here. And in my tools, I'll be using this time a 3mm end mill. My levels as shown over here, and in my technology exactly the way it was before, and in my link area again going down in a helical fashion. If we take a look at our simulation, you'll see that it milled out this area, but since this was a pocketed area, it could not clean out this area altogether, and for that we'll use a different operation to finish that off. In our next operation, we've actually used a rest machining option within a profile to finish out these corners. If we take a look at the operation itself, our geometry in this particular case is from here up until this spot over here, and from this spot over here up until this area over here. I'll be using a 3mm end mill, and in my technology I'll be using a simple finish cut with a link of tangent both for the lead in and the lead out. Now in our next operation, we'll simply finish up these walls around here, and if we take a look at the operation itself, you'll see that what we've done is we've used a geometry of just the outside wall using a 3mm end mill, where our upper level is over here and our profile depth is up until this step over here, a total of a 0.5 millimeter. We'll be doing a lead in of arc and also a lead out of arc. If we take a look at our simulation, you'll see that everything around there now has been milled out. Now in this next operation, what we'll be doing here is using again a pocket operation to finish off this pocket, and just to get into those corners we'll use the option of rest material. If I were to open up the operation, we'll take a look at the tool that I will be using, which is the 4mm end mill. And if I go directly to my technology, you'll see that we're using the rest material chamfer option, using rest. And in the data area, you'll see we put the previous tool diameter as shown here. Taking a look at our simulation, you'll see that the tool will go down and finish off that pocket all the way to that level where it should be. Now in this next operation, we'll be finishing off these corners over here using a simple profile operation with a clear offset, and again using a 3, and again using our T3 tool, which is a 4mm end mill. A quick look at the operation itself. Our geometries in this particular case are these 4 areas on top, as shown over here, and as I'd mentioned, the tool was my 4mm end mill, and in my technology area we're using the clear offset of 1mm with a step over of 1mm as well, approaching the part with a tangent and also doing a lead out of a tangent as well. Now for our last operation on this side, we want to finish off the top of this part over here. So I'll use a simple face mill operation to clean that area up over there. If we take a look at our geometry, the geometry itself is the boundary of the part. The tool will be a 10mm end mill, and in my technology area we'll be doing hatch, in other words going back and forth over the part. Taking a look at the simulation now of the part itself, you'll see that the tool will go down and work exactly over the part. Now we'll start our operations on the flip side of the part. And the first operation that we'll do here will be again using a face mill going over the part, using the 10mm end mill to clean the entire part, again using the hatch option. Now my next operation, I'll be using a pocket operation to clean out the area between the top floor and this area itself. Let's just take a quick look at the operation itself. You'll see that my geometry is this boundary over there. My depth will be going up until that step as shown over there. And in my link area, this time we'll be using a linear option, causing it to go back and forth. If I look into my data of my linear, you'll see that we have an angle of 5 degrees every single time. The length of each one of these lines is a total of 6mm before it turns around and goes in the opposite direction. If we take a look now at our simulation, and again we'll use the Solid Verify simulation, you see the tool will go down and clear out that entire pocket over there. We'll continue now in the next operation to do another pocket operation on this next area. Again, we've used our 10mm end mill, using the exact same technology to go down into that pocket itself. Now in my next operation, I'm going to do a simple profile operation just to finish off these walls over here. As you can see with my tool path, that's exactly that's being done over here. If I open up my operation itself, you'll see my geometry is that boundary over there. My tool is a 4mm end mill. My levels, just as in my pocket that I did before, up until that floor itself. And in my link area, we have a simple lead in and lead out of an arc of 2mm. Now, in my next operation, again, I'll do another profile operation for the same thing with the next step down for these walls, these areas over here, using the exact technology that I used in the previous operation. Now in my next operation, I'd like to machine out this area over here. So I'll use a simple pocket operation that'll clean out just this area. And if I take a look at the operation itself, we'll see my geometry, which is these areas over here. My tool will be a 4mm end mill. And in my technology area, I'll be doing a simple contour with a link using linear and a lead out of 2mm of a 2mm arc. Now if we take a look at our simulation over here, you'll see that it machined out exactly what I wanted. What's left over here, however, are these edges over here. For that, we use a simple profile operation around this over here. If we take a look at the operation itself, my geometry is this area over here, using a 4mm end mill again, and my levels exactly where it should be. My upper level being the top of that step, and my profile depth up until that floor itself. Using a link of tangent for the lead in and for the lead out. Taking a look at the simulation, you'll see that the tool simply goes in and clears out that entire area. And now we have those sharp corners that we were looking for before. Now to finish off this part, we have to do our drilling operations. I'll start off doing a drilling operation using a chamfer drill for these holes over there. Immediately followed with the same tool for these holes over here. and finishing it off with the same chamfer tool for these holes over here. Let's just take a look at one of the operations itself. You'll see that we have our geometry, we'll have our tool, and we'll have our depth using the diameter value necessary to complete that. The same thing was done with the next two operations, and the following operations just finishes off all the drilling operations here with the appropriate tool to do those holes. Now let's just take a quick look at the entire simulation of the entire part. You'll see that we have this side over here, the first side, then turned over doing the other side until we complete our entire part. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.